Welcome everybody. My name is Tim Skell. I'm an application engineer for ABB. You are using BACnet to obtain free LEED credits. If this isn't where you want to be, too bad. You're stuck in here. We're going to shut the door if you try to leave. Otherwise, we're going to leave it open. If you're filling out this paperwork, the session number is W2JF. And again, my name, Tim Skell. I've been in drives for about 10 years. Started out in the industrial and wastewater world, and for the last 6 years or so I've been doing HVAC. A little bit about how this presentation got to be. A couple years ago we started getting more phone calls from guys in the field. Hey, can I monitor kilowatt hours on your VFDs? Can I see that through serial communications? Yeah, we can do that. We're not really sure why the calls were coming in, but we were seeing more and more of them. And then one of the other guys was doing a presentation about 2 years ago and talking about serial communications and the abilities that the VFDs have. Somebody in the crowd raised their hand. So do you mean you can get me free LEED credits with your VFD because I can monitor kilowatt hours through BACnet? Maybe, what are you talking about? And that started the ball rolling, and found out that using some of the abilities within the VFD, you can save yourself from having to go out and buy additional metering and get yourself free LEED credits, and we'll get into that in a little while. We've got a small enough group, so while I'm talking, I'm more than happy to keep it informal, so if you have questions, don't be afraid to shut them out. So as far as the way the presentation is set up, we're going to talk a little about VFDs. I'm a VFD guy, so got to talk about VFDs. Then we're going to talk about LEED. And I'm going to do an intro to LEED. This isn't going to be a down in deep information on LEED. It's going to be more of an overview. And then we're going to do an overview on BACnet. And then we're going to tie everything together and show you how you can get the free LEED credits using VFDs to monitor kilowatt hours through BACnet. I'd highly recommend, if you're interested in the BACnet side of things, the serial communications, the person who's talking right after this session, Grant Wichenko, is really good with BACnet. He's going to be giving a presentation called How Facility Managers, Specifiers, and Equipment Suppliers Can Use BACnet Effectively. I'd highly recommend staying for that one. And then if you're here this afternoon, we're going to do one VFD communications, which objects should I monitor and why. So if you're interested on the serial communications to VFDs, come for the afternoon one. That's at 2:10. So what is a VFD? How many of you guys know everything there is about VFDs? There should be one guy in the group raising his hand. There we go. We got two. Okay. I'll accept the half. So variable frequency drives, you'll hear all kinds of different names for them. VFDs for variable frequency drives, AFD for adjustable frequency drives, freak drives, speed controllers, inverters, that strange box on the wall that I never want to play with, don't know how it works, but it does its job, whatever you want to call it. Basically what a VFD does is it's almost like a large light dimmer. So you can consider a big light dimmer, you're lowering the voltage to your lights dim down. Same type of concept for a variable frequency drive. You want to slow a motor down, you start to lower the voltage. Except notice we call it a variable frequency drive, not a variable voltage drive. In addition to changing the voltage, we also change the frequency. So if I'm at 480 volts, 60 hertz, that would be full speed. If I want to run that motor at half speed, well, if I cut the voltage and frequency in half, it'll run at half speed. So 230 volt, 30 hertz, now my motor's at half speed. I'm not going to get into the down and dirty details of how a VFD works, but when I have the opportunity, I like to mention that basically the guts of a drive, AC into a drive, converts it to DC, and then it converts it back to an AC-like waveform. Notice what's coming out of a drive is not some nice, pure sinusoidal waveform. The whole reason I show this is to remind people when you're installing VFDs, you don't put the input wiring and the output wiring in the same conduit. So for you guys who are managing buildings, doing maintenance, I always tell them when you walk up to a VFD and you're looking at it, you make sure there's 3 sets of conduit running into it. Input power, output power, and control wiring. If you start running input and output in the same conduit, you can get voltage induced into it. You can get noise issues if you have two VFDs and their outputs are running the same conduit, and you do a lockout tagout on one VFD, and you're expecting that motor to have no voltage at it. Well, guess what? If you had a couple wires running the same conduit, noise might have gotten induced into there, and there's actually some voltage there. So where do we see VFDs? Basically, if it's got a motor on it, there's a very good chance you can put a drive on that application. So your common ones are your supply fans, your return fans, exhaust fans. For me, coming from Wisconsin, my typical exhaust fan has a couple horsepower, 5 horsepower. Here in Vegas, it's 200 horsepower. I've talked to guys who have used VFDs on exhaust fans here, and they really don't care about ramping it from half speed to full speed, 3/4 speed, because they say, you know what, my exhaust fans pretty much run they run 100% of the time at 100%. But I think they're a little bit oversized for what I need. So they'll back them down and maybe run them at 59 hertz, 57 hertz, and get some energy savings, which we'll talk about later. So you can use VFDs to control speed and do varying speed. There's other guys who'll use them just as a soft starter and then to run at a fixed speed depending on the application. Cooling tower fans, booster pumps, condenser pumps, you guys can read. Just if there's a motor on it, there's a good chance you can put a VFD on it. So why use a VFD? I gave a little teaser there as far as soft starting is one reason you might want to put something on a VFD on it. Quick story, I was at a wake for a extended relative of the in-laws family, and they had an air handler on the roof, and that thing would start across the line, and every time it started across the line, the lights would dim a little bit and everything would shake. I swear the older people thought like the person was trying to talk to them from the dead. So I kept thinking, man, if I could just go up there and put a drive on there, forget even varying the speed, just to soft start the thing, I'd stop freaking all these old people out who thought that dead was trying to talk to them. So soft starting is one reason people will use VFDs. I mean, you start a motor across the line, you've heard those belts squeal, you've got all that inrush current. Your typical motor is going to draw a minimum of 600% nameplate when you're doing an inrush, and some of these premium efficient motors are even worse, to 900% current. So you don't get those peak current draws. You don't have to worry about your lights dimming when you soft start a motor. It's a lot easier on your mechanics. You don't have to worry about doing staggered starts if you got a bunch of cooling towers, and you don't have to worry about turning one on, now turn another one on, now turn another one on. As long as you're ramping them all up, you don't have that high inrush. Another reason people use VFDs is for flow control. You're looking for comfort, so I mean, you look at this room right here, they designed the air conditioning for this room, the HVAC system, assuming that every one of these seats has somebody in it. Well, obviously not every day is going to have somebody in every one of these seats like today. And it's also sized assuming it's 120 degrees outside, whatever the absolute warmest temperature is. So the HVAC system has been oversized, so what you can do is use the variable frequency drive to slow the speed of the fans down so you don't have all that extra airflow, that unnecessary airflow. And that's where you start getting into your energy savings. So you put a drive on something for flow control, and oh, by the way, you get a whole bunch of energy savings as a side effect. There's something called the affinity laws. So if any of you guys are pump and fan guys, you'll be familiar with these. Basically, your flow is proportional to your speed, and your power is proportional to your speed cubed. So as an example, if I want to go at 90% speed, think of 0.9 to the third power. So 0.9 times 0.9 times 0.9, which is 73%. So if I can slow something down 10%, I'm saving almost 30% power. And that's not just special with my VFD, at brand X VFD, brand Y VFD, that's a pump and fan curve. Those are affinity laws. To illustrate it a little bit, look at the blue line. So that's your flow. So we got speed down here, and your percent up here. So right here is percent flow. So if I'm at full speed, full flow, half speed, half flow. Now look at this one right here. This is your power curve. Notice when I'm down at 30 hertz, which is half speed, now I'm at 12% power. So there's a lot of energy savings there when you can slow down a pump or a fan. Now, keep in mind there's some other variables in there such as motor efficiencies and things of that nature. So it's not 100% following this, but as far as what the fan requires because of the application, follows these curves here. I just ran a typical payback estimation. Most drive manufacturers will have some sort of calculator where if you can give them the duty cycle of your application, they can plunk in the numbers and tell you what the payback would be on an application. So this example one, I defaulted at 12 cents per kilowatt hour, 20 horsepower, and I have it running 12 hours a day, 7 days a week, and put in a duty cycle here as far as how often it's running at what flow rate. And this particular example, compared to an outlet damper, gave about a 1-year payback, compared to an inlet vane, gave about a 1.5 year payback. So on a lot of VFD applications, the payback is less than 2 years. I will warn you, if you go to a VFD manufacturer and say, hey, calculate my payback on this thing, let me know how quickly this VFD is going to pay for itself. These estimations are only as good as the information you give the VFD manufacturer. It's your classic garbage in, garbage out. If you give us good information about what your duty cycle is on your flow, I can give you a pretty darn good, accurate payback. Any questions? You can also even, with certain VFD manufacturers, have the keypad display how much energy you've saved. This is something that you'd think, okay, well, why would I care about that? I put the VFD in there, I'm going to save energy, so be it. Well, if you're maybe trying to prove something out and you've got a couple applications that are retrofits, you know what, maybe this would be a good application for me to put a VFD on, but I don't really know my duty cycle, I don't really know how to calculate my payback period. Well, why not put one VFD on one of the fans or pumps? And VFD's got a learn mode. It can learn how much that motor was going to be drawing under full load. Now it can compare it to in VFD mode where I'm varying the speed of the motor, and it'll calculate how much energy you saved. And now if you did this on one pump or fan and it came back and said, yeah, I saved quite a bit of money over my first year, that then gives you the reason to go in and do the retrofit on pump and fan 2, 3, and 4. For the green folks out there, you can see the tons of CO2 that was saved also. Other advantages of VFDs, it's an automatic power factor correction device. I had a guy with some 200 horsepower motors who bought VFDs solely for the power factor correction, so he didn't have to worry about buying some other power factor correction capacitors. You get really good protection of your motor when you put a VFD on it. When you think of what you've got traditionally with a soft starter or a regular starter running a motor, if something was to short out, it could blow that starter, it could damage your motor if you're running single phase, so there's a lot of safety features built into the VFD. You've got current limiting, so if I got a bearing that's starting to seize up and the motor's now drawing more current, the drive can see that, it can limit the current, and if it's extended, it'll fault out to protect the motor from completely burning up. You've got ground fault protection, so if you've got a wire that shorts out to ground or a phase-to-phase short between the VFD and the motor, it'll give you a fault there. And also as a side note, we'll get into it, but all these different alarms and faults can all be communicated over serial communications through BACnet, so that you don't have to be at the drive to see exactly what's going on. It can pop up at the operator workstation in a different building, nonetheless, to see exactly what fault happened on the VFD. Motor temperature calculation, so if something's happening, I'm running really slow but at full current on my motor, obviously something's wrong, because on pumps and fans, your current's going to be a lot lower at the slow speeds. The drive can calculate what the temperature is of the motor and fault out on that. Phase loss protection is very handy, so if you had a fuse upstream of the drive or a wire loosen where now you've only got single phase, the drive can give you an alarm saying, hey, there's a single phase condition here, you need to go take a look at this, opposed to just putting single phase into a 3-phase motor, which could burn out the motor. And of course it's got under voltage sensing in it, so if you've got brownout situations and it gets bad enough, the drive will fault out opposed to burning up the motor. I have in red there the building automation system integration via serial communications. That's one of the things that in this talk today we want to tie together as far as how to get those free LEED credits. Talked about the fast payback. Drive's got troubleshooting assistance on it, and I have to watch myself a little bit, me being an ABB guy, and I'm used to talking about what my drive can do. So if you're buying the low-cost drive built off in some other country, there's a chance it may not have some of the features I'm talking about. So take a little bit with a grain of salt what I'm saying. You can assume some brands have it, some brands may not. Troubleshooting assistant, for example, the bottom right of that keypad has a question mark on it. So if I came up to a drive and it had an alarm on it and I wasn't sure what it meant or how to fix the problem, I can hit that question mark on it and it'll give me some step-by-step guides on what I could take a look at doing. And of course, without this, I wouldn't be in this presentation today. We have built-in energy monitoring, so I can see kilowatt and kilowatt hour. Other reasons you're seeing more and more VFDs out there is because you have to. There's no choice about it. ASHRAE standard 90.1 says, if you have a motor above a certain horsepower, thou shalt have efficient part load control of that motor. So the easiest way to do that is to put a VFD on it. And depending on it's a pump or a fan, there's different thresholds for where that rule is. And oh, by the way, if I want to have a LEED building, if I'm building a new building and I got LEED, ASHRAE 90.1 happens to be a prerequisite of the energy and atmosphere section. So from my point of view, a lot of new buildings typically are going to have VFDs in it just because people have learned the energy savings associated with it. What I'm seeing more and more of is people doing retrofits, saying, okay, I've got this existing building, I'm not using VFDs, what can I do today to get energy savings? Well, I can put a VFD on these pumps and fans, so that's a trend that we're seeing. I'm going to transition into LEED. Any questions on VFDs at all?
When you're adding a VFD to an existing motor, when should you consider a DVDT filtering or shaft grounding brushes?
Shaft grounding brushes, I'll take that one first. If there's a dedicated ground wire from the motor back to the VFD, I usually don't worry about shaft grounding brushes. Having that ground wire from the motor back to the VFD eliminates those type of failures 99% of the time. So with smaller motors that you typically see in HVAC, if we're dealing with a 500 horsepower water wastewater pump, I might have a little bit different answer. But for those that didn't hear the question or wasn't sure what the topic was, is there's a phenomenon where you can get when you're using a motor and a VFD, a charge to build up between the stator and the rotor of the motor, and it discharges through the bearing and creates a little spark, a little arc. And every time it does, it puts a little pit in the bearing, and it can cause the bearings to fail in the motor. Usually it's because of poor installation practices. Not every time, but usually it is. So the fix to that is to put a ground wire from the motor back to the drive chassis. When you have that, you usually don't get enough of that potential to build up between the stator and the rotor to cause that failure. The other question was, okay, I'm doing a retrofit. When do I use a DVDT filter? So I'm going to go way back here. Remember that waveform that's coming out of the drive? These are actually little tiny square waves. If you zoomed in on them, you see individual ones. Those come out of the drive 4,000 times a second. And that maximum voltage right there is about 650 volts DC. Your older motors have a 1,000 volt insulation rating on them. Well, if this peak voltage is 650 volts, that's not a big deal. But if you get longer cable distances with these older motors, there's an overshoot on every one of the little individual square waves, and that overshoot can double the voltage, so from 650 volts up to 1,300 volts. And when that overshoot happens, it eats through that old motor insulation. The rule of thumb is going to be dependent on the brand of VFD that you're using, because certain VFDs have different turn-on rates for each individual square wave that's coming out of there. The rule of thumb I like to use is 100 feet for initial gut check. It depends a little bit on the horsepower. If it's a smaller horsepower motor, I might use a 50-foot rule. So basically what I do is if I'm doing a retrofit and I got an MCC over here and I got with bucket with a starter in it and my drive's in some other room and I'm doing a retrofit and my cable goes up the wall and down the ceiling and down the other wall, okay, I got some good cable distance there. I'm probably going to either look at putting a DVDT filter on the output of the drive so I don't get that overshoot to happen, or I'm going to change out the motor to a new motor, which is called an inverter duty rated motor, which has 1600 volt insulation. Then you don't have that problem at all. So if you've got new motors, 1600 volt insulation, don't worry about the cable distance with respect to DVDT filters unless you're talking 600 plus feet. But retrofits, if you're in that 50 to 100 feet range or greater, you're going to have to look at changing out the motor or adding a filter. Any questions on that at all? Any other questions on VFDs? So everybody's an expert, right? I'm going to transition over a little bit about LEED. I'm going to start out by saying this presentation is geared towards LEED 2009. Some people call it version 3. Recently, they passed version 4, which is going to be kicking into effect later this fall, assuming things stay on schedule. So I will point out a few things in the PowerPoint that are going to be a little bit different for version 4 LEED. But LEED is Leadership in Energy and Environmental Design. And the whole purpose of this is, back in the day, people said, oh, my building's green, and I build a big green building. Well, what's really the definition of a green building? Well, my roof has grass on it. That's a green building. Well, not exactly. So LEED was developed to kind of help define what is a green building. So what does a LEED building get you? Well, in the long term, you save money. You're looking at your energy costs, for example. Conserves energy, reduced water consumption, improved air quality, increased property value. They've been around for enough now where I've seen a few studies where they're able to resale value on a LEED building is greater than the resale value on a non-LEED building. So you're starting to see that now. But just because it's LEED doesn't necessarily mean it's absolutely perfect. So your results vary depending on who designed it and what you actually did to make it LEED. My favorite part about LEED from a VFD manufacturer's perspective is they actually require verification. So it's not just upfront design. There's a lot of times where a consulting engineer will do one heck of a great job on designing a building, and the HVAC system and everything's really efficient. They have VFDs on everything. But at some point during startup, during commissioning, somebody went and maybe put the drive in hand mode. So normally the drive's in auto mode, it's listening to the building automation system, it's following the signal, what the BAS says. Well, I put it in hand mode and I just have it running at 60 hertz all day long. Okay, well, where's my energy savings? I'm not varying the speed anymore. You'd be surprised how often that happens, whether it's in hand mode or somebody has a bypass where drives will have a backup system, cross the line starters, they'll put it in bypass mode. And again, where's your energy savings? So LEED requires actual verification of what's going on in the building. So that's why I like it, because it verifies that the building is doing what it said it was supposed to, the way it was designed to work. Also, LEED is set up to have you always want to have opportunities to continuously improve the system. So it wants you to know what's going on. The more information you have, the more likely are you to have future improvements. Couple vocab items that got me when I first started talking about LEED. There's credits and there's points. The credit is the topic. The point is how valuable that topic is. There's different levels of LEED that you can achieve based on the number of points you have. There's just generic LEED certified, then there's silver, gold, and then platinum. So the more points you have, the better LEED certification you can have. There's LEED points spread across multiple categories. Sustainable sites, that one always gets me. You ask somebody what a sustainable site means, you'll 5 different people, you get 5 different answers. To me, a sustainable site means there's a whole boatload of VFDs installed there. That's what it means to me. That can talk over BACnet, of course, because if you have a VFD that can't talk serial communications, well, it doesn't really do much for you because it can't tie into the BAS and give all that important information. Water efficiency, pretty self-explanatory. Energy and atmosphere, and that's the section I'm going to be talking about specifically because that's where the VFDs and the energy savings come into play. Materials and resources, indoor environmental quality, innovation, and then regional priority. The innovation and regional priority aren't nearly as valuable as some of the other ones. LEED has varying requirements for new construction, existing buildings, and then it kind of breaks down the home schools because it kind of realized, one building doesn't fit all. There's different scenarios out there, so it's got a little bit different requirements depending on the type of building you have. And based on that type of building, those points for those various credits can be mixed a little bit. So as an example, I looked at material and resources. For new construction, that's worth 14 points. For existing buildings, that's only worth 10. Kind of makes sense. With a new building, you have a lot more control over what your materials are going to be compared to doing a retrofit. For those of you who want to be dangerous in LEED but aren't going to be a LEED accredited professional, what you can do is go online, and there's the official LEED book that's yay thick, and then they've got what I call the Cliff Notes versions. So you can go on there and say, okay, well, I want the LEED guidelines for new construction, and you can download this packet, and it'll give you an overview of all the different credits, the points assigned to them, what the intent of the credit was. And I'll, as an example, when I get done talking about this one, I'll read to you what's in here. And afterwards, you're probably gonna be like, Tim, you probably should have just read your presentation straight from this thing, because it's pretty straightforward. So first example I'm going to look at is new construction. I'm going to do two different examples. One is new construction, one is an existing building. So new construction is the first example we're going to take a look at. And there's a total of 110 points available. And like we just said on this previous slide here, you need a minimum of 40 just to be certified. So the more points you get, the higher the LEED certification you can have. We're going to look at the energy and atmosphere section of the new construction, and then we're specifically looking at credit 5. In 2009 LEED, credit 5 can give you 3 points, and that's regarding measurement and verification. So what the goal of this credit is to do is says, okay, you designed a building, you designed it to be energy efficient, I want you to prove it. So if you go ahead and read through LEED here, basically, develop a plan to evaluate building and energy system performance, characterize the building and energy systems through energy simulation or engineering analysis, install the necessary metering equipment to measure energy use. Install the necessary metering equipment. So as soon as people read that, they think, well, I need to go out and install a whole bunch of meters. What did I say earlier? VFDs can measure kilowatt hours. But the whole goal here, like I said, is to make sure that the building is actually acting the way it was designed. So what's going to happen is you're going to install metering, or if you happen to have a VFD that has the metering built into it, you're going to have that in the VFD, and then you're going to take a look at the energy consumption and verify this actually matches or is in line with the original design. Who cares if I designed a really efficient building if it doesn't actually operate efficiently? So this is all about verification. Remember I gave that example earlier where people put the drive in hand mode so it's no longer listening to the building automation system, or they put the drive in bypass mode so it's running at 60 hertz. That's going to get caught when you're metering the power, and you're going to realize, hey, this is drawing way more power than we anticipated. VFDs are used in other credits too. I'm just pointing out specifically a couple of them here regarding how you can get some free LEED credits too. So like I said earlier, VFDs are a requirement of ASHRAE 90.1, and ASHRAE 90.1 is a prerequisite for new construction. There's other advantages to monitoring power going into a drive other than just the whole LEED topic. if all of a sudden I see that my drive is drawing more current or more torque, depending what I want to monitor for accuracy, to get the same amount of airflow, well, geez, maybe I should go in there and change that filter, because that air filter is getting dirty. If I see current bouncing all over the place, and maybe I've got a slipping belt. So there's a lot of troubleshooting information you can get too by having the building automation system monitor the power. So again, new construction, the whole intent is we want to meter the power to make sure what's going on in the building matches what was designed to go on. Here's a nice eye chart for you. What all this is a checklist for the different items. So you've got your sustainable sites, you've got your water efficiency, your energy and atmosphere, and here's the credit we were just talking about. It's worth 3 points. Materials and resources, and so on for the different items. So first example we did was new construction. Next example I want to do for you guys who have existing buildings, and well, I don't have any new buildings right now or nothing being built. I care about what I've got already existing. That would be this next example here. So hop on the US Green Building Council website and download my Cliff Notes for the existing building. And if I did that, I'd see that, okay, again, I got up to 110 points is available. 35 of those points is through the E&A section, and I'm looking at credit 3.2 now. 3.2 is performance measurement. Okay, well, my building's already existing. I don't really know how it was originally designed, so I'm not worried about putting the meters in there for that reason, but I need to put the metering in there to learn about what's going on. I've got an existing building. It's 20, 30, 40, 50 years old, or however old it is. I don't really know what's going on. Step one is to get the information. So this LEED credit is about learning what's going on in my building so I can then come up with a plan to improve my energy efficiency. So depending on how much metering you do, 40% or 80% of your total loading, you can get a different number of points assigned to it. So again, the average guy who's not familiar with the down and dirty details of what's in a VFD is going to read the LEED standard and say, okay, add metering. Okay, I'm going to go out and spend $1,000 a piece and go install a bunch of meters. You don't really need to do that if you get a VFD that has the kilowatt metering built into it. So existing buildings, we need to learn exactly what's going on, and then we can come up with goals to reduce energy.
Back on the last slide, could you give us a little more nuts and bolts perspective on how you would use your BACnet information to actually identify opportunities for savings?
First, you have to figure out where your main power consumption is. So from the BACnet point of view is you're mining data. So for me, from a VFD manufacturer, I don't necessarily say, okay, here's your savings, here is your savings. My goal is to get the information to somebody else so they can go ahead and figure out where my energy savings is going to be. So that's when you bring in a third party who deals with that, and they can help identify that for you. There's some contractors. There's certain contractors that are designed specifically about energy savings, and that's what they go to market as doing, and they deal with retrofits and things of that nature. So just having the information isn't the solution. Getting the information is part of the solution, and that's the next step. And that's above and beyond what I really get into as a VFD guy.
Examples are peak load, avoidance. You can compare the drive load to whole building load and implement a strategy to shed load when you're about to set a new peak demand. The smart grid, you can use that information as you know the time of the electricity cost is going up. You can send new set points to all that fan drives and bring them down a little bit to take advantage of the higher
That's why guys like him get paid the big bucks. It's more than just a niche market that's developing exactly for that. This is just another checklist, same type of thing we had for new buildings. Well, it's the same checklist for existing buildings as far as here are the different topics, here are the different points assigned to the various credits under those topics. And right there is either the 1 or the 2 credit, depending on how much metering you're doing. And it makes sense. The more metering you're doing, the more you know about your building, so you're going to have more opportunities for improvement, so we're going to give you more credits for it. So how do you achieve the credit? Well, like we said a couple times, you have to do the metering. A lot of guys still out there using standalone meters, putting a $1,000 meter out in front of the drive, and then one of 2 things. Their best case at that point is they've got their meter hooked up through serial communications to the BAS, so BACnet is the most common. Worst case, they got a guy with a clipboard walking around once a month taking all that information off the various meters. So hopefully that's not the case, but we do see it. So if I'm looking at a project, first thing I want to do is make sure that I'm putting a VFD in there that can actually monitor the power. And the next step is I want to make sure that that VFD can monitor power and then display that information through serial communications such as BACnet. And I keep pointing out BACnet because that's where we see the industry going for HVAC, open serial communications. Metering itself does not give you the credit. To your point, okay, I got a bunch of data, so what? That doesn't do anything unless you do something with the data. So none of this metering gives you the credit itself. You need to do something with the data, and that's where these guys come into play. So if you get rid of that meter and use the VFD to monitor the power, you don't have to worry about that initial hardware cost. You don't have to worry about a guy going around with the clipboard. If you want to know if a VFD can monitor power, I just took a screenshot of the user manual here. You can see this on the keypad at any given moment. It's also resettable, so once a month I can go in and reset it. But since I was smart and I picked a VFD that can do this through serial communications, here's my BACnet points list, and hey, I can look at my meter right here. I can look at that analog value point through BACnet and say, okay, here's how many kilowatt hours I used. I can reset that and then check it again a month later, and I can mine that data. So I've mentioned BACnet a couple times. That's the way we see the industry going. It's an open protocol. Once upon a time, we had the big boys and everybody had their own proprietary protocol. And once they got into your building, you're kind of stuck. Okay, well, I need to use brand X because that's what's in here right now, and I want everything to talk and play nice to each other, so I'm locked into brand X, which is nice until prices might start getting bumped up, or there's a relationship falling out, or maybe the support's not what it used to be. So BACnet was developed so I can take products from different vendors and I'll put them on the same wire and have them talk to each other. There's a BTL, BACnet Testing Labs. That means it's been sent in and actually certified by a third party to make sure it will play well and it meets the BACnet standard. You do see it built in on a lot of products now as standard. Certain items is still a plug-in card, or you might need a gateway, but a lot of VFDs that are dedicated for the HVAC market, VFDs, will have BACnet native, so there's no plug-in card, it's built onto the drive. I won't steal too much of the 2 o'clock's presentation, but really what you see is serial comms going into a drive. A lot of times you'll see the hard wiring of the start-stop and your safeties and your speed signal, and then the serial comms will be monitoring. So that's where you will be watching your kilowatt hours and maybe looking at what fault might be active. So your control is done hardwired typically, and we see a lot of the monitoring through serial communications. Doesn't mean that's got to be it doesn't have to be that way. So if you've got a nice reliable network, you can do your start-stop speed control over BACnet or whatever serial comms you're using, but that's kind of the trend that we see. Serial comms is great for troubleshooting. Mentioned earlier, if I got a couple different buildings and I got my workstation here and I find out I got an alarm on a VFD in a different building, I can pull it up on my computer. I can say, okay, well, I got an overcurrent fault on this drive. If I see it's a non-important fault, like an overvoltage, maybe we had a lightning strike come in, so the drive just tripped out to protect itself. maybe I just go ahead and reset that fault on my computer opposed to sending somebody over there. Or if I do send somebody over there, I can give them a heads up of what to look for before it even gets there. And as I mentioned, there's no extra hardware needed on a VFD to monitor power, and you can see that over BACnet. Hence, it's free part of the topic. So, recapping, bringing it all together. Good portion of the VFDs out there monitor power. Some of them, you can see that power over serial communication, such as BACnet. You get LEED credits for monitoring power. So if you have the building automation system, talking to the VFD, looking at what the kilowatt hours are, that's a step towards getting your free LEED credits. Questions? Or group conversation on anything? Somebody over there had one. Yep.
You see, you get LEED credits for measuring power. So, what if you were just measuring the VFD, you weren't measuring, say, other circuits? Like, how can that qualify you for LEED? Would you have to do it for everything, or just for something?
It's not, you can't just monitor only the VFDs and nothing else. Like the existing building, for example, they had different thresholds for monitoring 40% of the building's power and 80% of the building's power. So you do have other metering. We consider this to be at the sub-metering level because it's at the VFD and not further upstream. So there is other metering that you have to do, and that's where you'd have those revenue grade meters up there.
Another question, because I'm not really in the VFD line, like you said, using serial communication, VFDs, are they going to go to, like, BACnet, presumably there's BACnet IP and BACnet MSTP, and like, why aren't, is there, I don't know, because I'm not in that field, is the VFDs, are they heading towards BACnet IP, or what's
Where the VFDs are in the circuit, it's usually the MSTP is what we see. So the IP is further upstream in the network at the level of the drives. We're usually on the MSTP side, so there's going to be a router between my drive. So does that answer your question?
It's not a peer-to-peer device typically. The VFD is, if you will, a slave device. And the things today that are on the IP network are peer-to-peer, other building controllers. But in Europe, it's definitely a trend. And we have BACnet IP capability that now it is an option card to get the drive up to the IP level. Next generation drives, it's going to be built in.
Because like I'm in light control, and it's we offered initially an MSTP, and we realized no one wanted it. Just even though from a traffic point of view, you don't need it, but it's just like it's just for whatever reason everyone wanted IP, and then we got stuck. And so someone who actually wanted MSTP, we had an inverse router for it. It just was interesting about VFDs, but where they were heading. But thank you, I appreciate it.
My view is that it's coming. It's not here yet, but it's coming.
And it's coming, but it's a ways off. I mean, for what we see most of the time, it's going to be MSTP.
In your personal experience, when you're looking at proposing VFD projects, just ballpark, what's the range of some of the returns that you're able to discuss?
I usually tell people to look for a 1 to 2 year return on investment. It depends a little bit on the duty cycle and everything, but also depends a little bit on what your installation costs are locally. Some parts of the country, the install costs are a little bit more for your labor and things of that nature, but a 1 to 2 is a good starting point.
Including installation costs.
And that's looking just at energy. I mean, the advantages of having BACnet network and the ES system and the analytics is that you can then do local proactive target maintenance. So instead of walking around checking all your VAVs, a third of them every year, you can actually get performance data directly from the device, walk around and only fix this bottom third that are performing in the bottom third. So you're actually doing that maintenance instead of sneaker checking every single VAV you have.
We got 4 minutes left. Anybody else has anything else?
One thing, when you're talking about changing from a constant volume to a VFD, say in a pump, when would you consider the cutoff point of changing the motor to an inverter type motor or keeping the existing motor? What would be your gauge on that?
If I'm doing a retrofit job, so it's got the existing motor, I usually, if it's a closer cable distance, so I don't have to worry about the filtering, if it was my money that I was spending on it, I would probably reuse the existing motor unless it was 30 years old or something where I was kind of expecting the maintenance aspect of it, the bearings and everything, that I'm gonna have to get a new motor anyway. But unless there's a reason, I don't change out the motor if it was my own money. Now, if I got a critical application and downtime is very important and I can't afford to have downtime, in that situation, I would change out the motor. So if I'm talking hospitals, I'm talking data centers, I would just be changing out the motor. But if it was an office building and it was my money I was spending, I would reuse the existing motor if it was close to the VFD, so I didn't have to worry about the filters.
And you can do a payback analysis on, it's a 200 horsepower and it's 80% efficient, and modern motors are 95% efficient. I mean, the VFD is gonna prop that efficiency up anyhow, so it's not as bad as, on the starter, it's a no-brainer. That 15 or 20 points difference in efficiency is a no-brainer. But the VFD does most of the energy correction already. But there is a point when you get to a certain horsepower that the efficiency, it's more a 5-year payback instead of a 1-year payback like the VFD, but there is a payback on the motor.
Come on, a couple of you guys are quiet.
Good job, Tim.
For anybody who is doing the learning assessment questions, the true-false questions for the continuing education, when in doubt, I'd suggest circling true. Okay, thanks guys.